In the last lecture, we have motivated now the need to transform a tensor into a different set of axes. We've already shown that a force or a displacement could be transformed into a different set of axes. But we've motivated both with a couple of examples of experiments, plus since we've already done the vector transformation, we now want to go back to the example that we just talked about, which was if I have the case of conductivity, which is nice because the second rank tensor allows us to do everything without getting too complicated. And we had mentioned that we'd like to be able to just go straight into understanding the tensor in the new coordinate system, since J and E are defined in the new coordinate system due to experimental variables, typically, experimental conditions with a sample size, sample cut, for example, or just dealing with, in the case we showed you, maybe I have two different phenomena occurring in different reference frames. In order to understand what's going on in the material, I need to bring them together. So in either case, I'd like to transform the sigma ij into that new. So let's think about this in a generic way then. So let's go back to the generic case which we had done before. Some displacement qi equals a ij pj. That was our very generic first case, so let's just make sure you understand this is true overall. So remember, we're going to use this terminology new and old. So new is with the prime and old coordinate system is without. Okay. So to do this, what we want to do is say, all right, let's take q prime in terms of q in terms of p in terms of p prime. So you see how this works. The original expression is q in terms of p, which is the central thing. But if I put p in terms of p prime and I put q prime in terms of q, then that gives me a direct length of q prime to p prime, and that should allow me to understand a ij prime out of this whole thing. Because at the end of the day, what I'm after is that. So I want to go from where we are right now, and this one, all the way over to that one. So let's write these expressions. We already have all the tools that we need. We've already done all of them. So qi prime is equal to c I m qm. So let's see what I did here. CIM, and we're starting with the left side, is this one is new in terms of old. So essentially we've done what we normally do, is that, here's the old coordinate, the old part of the vector. Here's the new transformation ij, and we put it qi. Now the reason I changed it to m and m is because we know that j is going to be way over on the other side here, because remember it's pj prime, okay? So as we move across here, we've done this first part. Now you might say, well, why didn't I go, if it's going to be I over here and j over here, and I'm going to have to move over in, you know, the next ones, it should have been I, j, k, right? And you'll see that some people use k. K is generally avoided because of its use in wave vector, so a lot of people avoid it. So instead of using the next logical variable, we're going to jump over k and use I, j, k, l, and m. So we're going to use m and l. I guess I could have used l first. Doesn't matter, but I'm going to use l and m. Okay. So now let's take qm, right, and use our central expression over here. That this one we know very well. Oh, sorry. We have to do it now in terms of ml. So this is nothing more than this term over here. I'll circle those to make sure you understand that. This one is what we started with over here. But we changed the indices because qm is over here. So I'm using qm. Because remember, I got q prime in terms of q, right? Now I want to get the qm in terms of p. So I just have to use indices for going across here. So this is m, so I already used m, right? And remember qi, I is here, so this becomes m. The next one I'm going to make is l, and I put l there, right? So that's this middle one. Then finally we need to get p in terms of p prime. Now this one has a small subtlety in there, which we need to pay attention to. So here's pl, remember, just bring this notation over. So pl needs to be in terms of pj prime. Remember, that's our goal, right? So remember, they're related by a c, just like this transformation, but remember, it's the other way. Here, it's old in terms of new. So in that case, you know, I would think that this is going to be plj, right? But it's not. It's going to be jl. So remember I was telling you about the importance of the sequencing of the indices. Here's an example where you can make a big mistake. And in fact, just to make sure I re-derived everything because I was very nervous about this. Oh, sorry. Here, I messed up actually. Yeah, no, this is right. Yeah. See, I'm still double checking everything. So PL equals CJL I at J. Now remember how normally you would take L and you'd put that first. But that's because in this system over here, when we went from, and we still have to remember which coordinate system we're talking about. When we went from Q to Q prime, and we use that direction of indices, right? That's in going from the old system into the new system. Because we're going from the old system into the new this direction. Remember, this is old into the new this direction, right? This is old to the new in this direction. We have to use the opposite sense, okay? So that's why the J appears over here instead of next to it, okay? So again, just think about the new in terms of old and new, and keep that in mind. So prime is new, and without prime is the old system. So that's one really key thing to keep in mind. So now we can put all of these together. And so we end up with qi prime equals cim L C J L P J prime. So clearly now this is what we were after. So A I J in the new system, right, equals C I M C J L A M L. So that is saying I have a tensor and it can be transformed by two transformations. As long as I'm going in the correct direction, I can transform it by transforming twice with the transformations for Q to Q and P to P in the correct reference frame. So it's a shortcut. I don't have to, transform everything in the entire thing. I can take this shortcut. So now we can kind of apply that. Let's first of all write out what such a thing could look like. So let's just kind of give you an example here. So let's look at the case for A12 prime as an example. Just one element. So that means, remember that we're summing, right? Remember the fact that M appears twice and L appears twice. It means that we're summing over those variables. So I'm just being very complete here. And the 1 says that I is 1. So this is 1M C. And then J is 2 in this example. So 2L A M L. So what I would do is in this internal one, I would add the terms for L going from 1 to 3, right? So this would be first 1, 1, 2, 1, um, uh, uh, 1, 1, for example, right? Plus the next one, etc. And that's, for each element, you would have that. Now you could see that for elastic constants, if you have a complete elastic constant triclinic system CIJKL, it's quite a transformation, right? Because you got 4. I'm only showing you a tensor rank 2. A 4th rank tensor, you'd have 81 squared times, I think, something like 5. So there'd be a lot of elements to figure out. But you could see how you could, write out each one of these and transform our second rank tensor. So the good news is something we'll talk about next, as you know very well. So in a lot of the cases, except for triclinic crystals, sorry if you have to work with them, but in a lot of cases we can use the symmetry to realize that the tensor has missing elements. So instead of looking at all of the A, I, J, we can pretty much eliminate many of them, especially in very popular crystals like cubic crystals. And we'll talk about that in the next lecture.